Now, after that, we have got our baseline or the initial results. We'll go next with the hyperparameter tuning. So I've just added some notes, to keep everything neat and, organized. So on this step, as we mentioned, that we have done some comparison for the models that we have, 3 models that we have. Here I just added like 0.7. If you recall uh, the main roadmap that we are going through is here, including defining the problem, doing an EDA. So we imported the required libraries. As let's consider this as a reminder to us how we are going through each of these steps. So we imported the required libraries, we loaded the data set, we performed some EDA, we pre-processed the data, then we train and just split the data, and then we trained our model. As you could see that we have chose the logistic regression, random forest, and KNN models. Then we are on 7. We evaluated our model. So we are done from evaluating our model, and we created some comparison for each of these models. Let's now go to the 8th step we have on our roadmap, which is the hyperparameter tuning to improve the model accuracy. So I've just set it some simple examples on the hyperparameter tuning processes, how we can do it. We'll look into different topics, including the hyperparameter tuning, also the feature importance. The feature importance, we already covered it. If you recall that when we defining the correlation matrix between the dependent variable and the independent variable, or we call them the features and the target variables, when we created the correlation matrix, the confusion matrix and cross validation, we're going to look into that. And these are the main criteria that we are evaluating our models based on, including also the accuracy that we have found here. So these are the baselines accuracy percentages or accuracy scores for the 3 models. But we are also going to cover the precision, recall, F1 score, and the classification report. Classification report is just a summary of all of these scores. We'll look also into the ROC curve and AUC curve also as well. To start with the hyperparameter tuning, so what exactly is hyperparameter tuning? Let's summarize it as we can think of, it's a process of finding the best set of hyperparameters for the machine learning model to improve its performance. Hyperparameters are parameters that are set, before the training process began. So we already had here, we haven't changed any of the hyperparameters, and we moved with the default ones when we trained our data here. Okay. So it's mainly, you have to set that, before the training process begins. So what you expect next is we might, start, again, training the data after we, change the hyperparameter or settings of the models. So we are gonna redo the training process, but you already have the process up. And these hyperparameters, control the aspects like the model complexity, the learning rate, how complex your models is going through the data. Does it go 100 times? Does it go 20 times? Does it go like 2 times? All of these, we call them like these settings or the hyperparameter of each of the model. Also the learning rate, as I mentioned. The regularization and the training process itself. Unlike model parameters, model parameters are different, which are learned during the training, such as the weight in a neural network. Hyperparameter must be set manually or through automated search before training. So to recap on what are the hyperparameters, like as we said, that each machine learning model has a specific hyperparameters or settings that control its behavior. For example, let's take our decision tree that we are having as one of our models here. We have the random forests. So let's take an example of the decision trees. So the decision trees, you can think of the max depth of the tree is one of the hyperparameters which you can set. Also, you have one hyperparameter called minimum sample split, which is equal to the minimum number of samples required to split a node. Also, you have something called the minimum sample leaf, which also is used for the decision trees model. So you can think of, modifying this hyperparameter to ensure that your model learns not too complex, not too slow, but it gives you the highest and optimum results, such as the accuracy or precision or recall. Let's now talk about the importance of these hyperparameter. As you recall that we said that this is very important for the model improvement and the model performance improvement. Let's say that as its performance improvement. So the right hyperparameters can dramatically improve the model accuracy, speed, and the generalization ability, which is able to generalize or learn the patterns within the data. Also, one thing is important here is the model optimization. So different hyperparameters can lead to models that either overfit when you have too complex processes, or hyperparameters that ensures to go to each of these data cell. Sometimes we call it as an overfit because it goes too complex to the data and it's very slow. Sometimes it's used for the medical field, since the errors are not acceptable, especially in the medical field. The next model optimization that you have is the underfitting, when you just set the hyperparameter to be too simple, too fast to learn, so it does not learn or detect the real patterns within the data itself. So it's very important to tune them to find a good balance between both of these, depend on the requirements that you have. Next, we are going to discuss how we can find the best parameters, or how we can start tuning our hyperparameters. So stay tuned for the next session to discuss how we can find the parameters, how we can tune them by hand, or we can find the best settings using different strategies like the GridSearchCV to find the best hyperparameters within each of the model.